Hello, good morning, students. Today we are going to discuss limit of a function, of course, at a point in its domain. So I have written limit. What is that? Okay, of course, we are going to discuss. Before that, we have to understand some symbol. We can say let us write notation. First of all, the first notation I am going to use is this one. You can read it as x tend to a or x approaches a, or okay, different way you can read. What do you mean? X is very close to a. It's a number very close to a. In other words, you can say x minus a difference is very small. The difference is very small, you can see. But it is not zero. X minus a, the number is not zero, but it is very small number. That is, x minus a is a very small number, maybe positive or maybe negative, but it is not equal to zero. In number line, if I consider a is the number somewhere here, x is very close to it, means x lies somewhere, maybe towards the right, maybe towards the left, but somewhere, okay, in this neighborhood. But in mathematics, we must define it precisely. What do you mean by neighborhood, or how close it is? So that's why you can say how close. Suppose if the number is a, suppose this particular length is k, or this particular length is suppose k. So what about this point? This point is nothing but a plus k. Yes, and this particular point is a minus k. So x tends to a means we allow something or the numbers in between a minus k and a plus k, or we allow x in this particular interval. Do you get it? X must be, or you can write x is less than a plus k or greater than a minus k. We can write this way. Got it? So if I don't mention k, you must assume that x tends to a. It means x is very close to a. That means, however small k or a number you choose, we can have x within a distance of that one. So you can write mod of x minus a. That is the difference of x and a. And why I am using mod? Because it can be negative. The difference is less than k, because k is a positive number. I have chosen k to be a positive number. So difference of x and a, the difference is less than k in absolute value. X is very close to a, but x cannot be equal to a. It is around a. Okay. Okay. Let us use some other symbol that is almost similar. X tends to a plus. Why? Okay. Let us write the meaning. So here I consider only the right hand part. That is, x is very close to a, but not towards the left. That is, in this portion, x is greater than a, but very close to a. So it is very close to a, but x is greater than, or you can write x is in the interval maybe a to a plus k. Earlier I had, yes, a minus k to a plus a. We had both sides, but here we allow only the right hand side. Similarly, we can have the other one. Okay, you know what is that? It is a minus. So here a minus, x tends to a minus means again x is very close to a, but it is less than a. That means now we allow this particular interval. Or here I can write x belongs to, can you tell me what should I write?
A minus k to a.
Okay, a minus k to a. So x is less than a, but it is not much less. It is very close to a. Or here in symbol I can write x less than a, but x is greater than some a minus k. K is very small number. You can choose k, h, or any other symbol. So later we will choose some standard symbol used in mathematics. Okay, here in every cases I have used k positive. So can you tell me what is the value of 0 to the power 0? Anyone?
Sir, 1.
1.
Okay, confirm.
Yes, sir.
You are confirmed because you got it in your book, isn't it? But let me tell you, 0 to the power 0 is never 1. So why so? Okay. What is 5 to the power 0? Can you tell me, any one of you? Okay.
1.
Okay, it is 1. Why? I can prove it. Okay, let me prove it. So I can write 0 as 2 minus 2. Yes. Now I have a result. If you remember, a to the power m minus n equal to a to the power m by a to the power n. All of you remember? So I can write this one as 5 to the power 2 by 5 to the power 2. In other words, I can write 25 by 25. And you know 25 by 25 is equal to 1. So I get 5 to the power 0 equal to 1. Or you should any number other than 0. Okay. That number to the power 0 is 1. You can prove similarly. Okay. You got it? But if I have to prove that way, it is 0 to the power 0. If I write 2 minus 2, what do you get? 0 square by 0 square. What do you get? 0 by 0. Is it 1?
No, sir.
Undefined.
Not defined.
Okay, it is indeterminate actually. Let us consider this function. As I said, 0 to the power 0 is not 1. What do I mean? I mean that f of 0 is not equal to 1. Yes? Now if I ask you some other function like f of 1. What is f of 1 here? It is 1 to the power 1. The value is 1. Yes? What is f of 2? It is 2 square. It is 4. What is f of 3? It is 3 to the power 3. It is 27. Now we are trying to find f of 0. But 0 to the power 0 you cannot find. It is indeterminate. Now we choose some other number. That is why should I go 3, 4, 5 this way? Let us come towards 0. Okay, I tried f of 1. This 1. Now try suppose f of half or maybe 0.5. Try to find it. What is the value? 0.5 to the power 0.5. Okay, if try to find it yourself, then suppose f of 0.25. Okay, it is 0.25 to the power 0.25. Then f of maybe 0.1, maybe 0.1. So it is 0.1 to the power 0.1. At least you can use your calculator and find it. Next, suppose f of 0.01. Okay, it is 0.01 to the power 0.1. You can find it. Then suppose f of 0.00001, more closer. Okay, you can find it. Okay, so you come closer to 0. As I said, x tends to 0. The meaning you know. Now what to do? Come x tends to 0. Try some other number. Maybe like this. 1 to the power the same number. Okay. So if you go this way, if you come closer to 0, you see the number is almost equal to 1. The more closer you are to 0, the more closer you will be to 1. Do you understand it or not? If you go, as I have discussed the meaning, if you go towards 0, this particular function will go towards 1. Do you understand it or not? You
Yes,
can try.
sir.
You can try
Yes,
with
sir.
calculator, and I hope you can try it. So the more closer you are to 0, x to the power x will be more closer to 1. You can try it. It seems that x to the power x is 1 when x is close to 0. That's why we write this way. Or actually, we should not write 0 to the power 0 equal to 1. The limiting concept is this way. You should write this way. Okay? Or in terms of limit, we write this one as x tends to 0 of x to the power x equal to 1. We should write actually this way. The meaning is when x is very near 0, x to the power x is very near 1. So these two are equivalent meaning. This one and this one. Although x to the power x limit x tends to 2 is 4, but you cannot exactly put 2 to the power 2. What you can do, the meaning says when x is very close to 2, you can try, you put 2.0001 to the power 2.001, you will get something very close to 4. You will get 4.0001 maybe. So you
Yes,
get
sir.
that. Meaning is not that whenever you put 2, you get 4. It is not so. Whenever you put something very close to 2, you will get something very close to 4. That is the meaning.
Okay, sir.
Okay, any doubt, any more? Okay, let me write formally the meaning of limit. Then I will explain, of course, what do you mean here. We must observe it. So the last thing, let us consider what I have written fx approaches L as x approaches C. So earlier function was x to the power x. When x is very close to 0, x to the power x is very close to 1. So if I have a general function, if I have any function, whenever x is very close to some number C here I have used, then fx approaches L. Here it is not 1, so some number, and there is a general concept. Okay. So symbolically we write fx tends to L as x tends to 0. In other words, as I said, I write the meaning is x is very close to C, then fx is very close to L. Okay, do you understand it? Forget about the first part here. Limit x tends to C, fx equal to L. It means whenever x is very close to C, yes, fx will be very close to L. So, but mathematically we have to explain it. Okay, precisely. So when x is very close to C, what do I mean by this? Okay, as I said, the meaning, it is very close to C, but not exactly C. And fx tend to L. Okay. Now, how close? If fx is very close to L, but question is how close? closeness should be defined. So in terms of symbol, what we mean, I mean x is not equal to c means x minus c is not equal to 0. Yes, and fx minus l may not be equal to 0. But the meaning is they are very small. These two quantities are very small. How small? The meaning, limit actually meaning is how small it is as much as you want. So if you give me any number you give me, any small number, I can make this quantity fx minus l smaller than that one. That is the meaning. Do you get it? Fx minus l may not be 0, but it is very small. Very small means you give me any small number, I can make this difference even smaller than that. How? I will choose x much closer to c, depending on your number. If you give me any number, maybe you can 0.00001. If you want me to make this difference smaller than that one, I will choose x such that x minus c is even smaller than some other number. I will choose some other number, maybe any number. Okay? Do you understand it? As much small you want this quantity, I can make it. Depending on x, I will choose x more closer to c. Fx minus l, this quantity may not be 0, but I can make it as small as you want. If you give me a very small number, but I can make this difference even smaller than that by choosing x suitably. How suitably? Closer to c. Mathematically, how do I write? So if you give me any, do you see any epsilon? This one is a Greek symbol, so I have used instead of some number. So if you give me any epsilon greater than 0 position number, what I do, I can make the difference fx and l smaller than that one. How? I will direct this means I can choose. If you give me epsilon, I can choose another number delta. How? So that my x and c, the difference is smaller than delta. If I choose this way, fx and l, the difference will be smaller than epsilon. Do you get it? So if you give me any epsilon greater than 0 position number, of course, I can make this difference because I have used both side here. I can make this difference smaller than epsilon by making x sufficiently close to c. How sufficiently? I will have another delta, another symbol, so difference is smaller than that one. So that is a mathematical definition, or precisely you can write. But if you simply write this way, that is limit of fx as x tends to c is l, it means when x is very close to c, fx is very close to l. That is the meaning. Okay, should I explain more or you understood?
Understood, sir.
I can write limit x tends to a plus. What do I mean by this? This x is very close to a, but x is greater than a. But earlier, when I write limit x tends to a, it means it is a or c. Okay, let us use the same symbol c. Okay, c plus means here I allow x to be greater than c, but very close to c. Okay, I can have something. This one also. This one is known as left hand limit. Sorry, right hand limit c plus. Or you can say it is right hand limit. Right hand limit. The same meaning. Okay, whatever be the number. If the number is suppose l or suppose k, it means when x is very close to c but greater than c, fx approaches k. Okay, we call right hand limit of fx. Okay. Similarly, I can have x tends to c minus, or I can write f of c minus, and we call it left hand limit. Left hand limit. In short, so the meaning is when x is very close to c but less than c, fx approaches the number, maybe here m, something like this. Okay, and when limit exists, only when these two limits are same. Sometimes I will have some situation when left hand limit and right hand limit are different, then the limit does not exist. So let us write formally. So limit f of x tends to c exists if both, okay, then let me write x tends to c plus, that is fx, and limit x tends to c minus fx, both exist, both must exist, there should be some number, and they are equal. They are equal. If both are equal, if x is greater than c or x is less than c, but sufficiently close to c. If both cases we have some number to which f approaches to the same number, then we say the limit exists. That is, if both left hand limit and right hand limit exist and they are equal. Sometimes we can have that they are not equal. So in that case, we say the limit does not exist. So let me give one example where limit does not exist. I am going to show that limit does not exist. Why so? Although the limit, both left hand limit and right hand limit will exist, but here the limit does not exist. Why? Let us first consider the right hand limit. X tends to 0 plus. What do you mean by 0 plus? 0 plus means x is very close to 0, but x is greater than 0, isn't it? Here x is greater than 0, isn't it? So if x is greater than 0, I can write mod x as simply x, isn't it? If x is greater than 0, mod x is nothing but x, because if you have positive number, maybe 0.0001, it is simply that number, 0.0001, isn't it? So I can simply write this way. If x tends to 0 plus, it means x is positive, or in that case, mod x is nothing but x. So what do you get? So now you see x is close to 0, but x is not equal to 0, isn't it? So however small number may be, x is not equal to 0. So it may be like this 0.000001. I cannot have 0 by 0, or I cannot have the exact value of 0 by 0. But I can have the value of x by x when x is not equal to 0, because x tends to 0 plus means x is not equal to 1. X is greater than 1. X is positive number. If we divide a positive number by the same number, what I get? I get 1. Isn't it? Any doubt?
Yes, sir.
Yes, sir. Yes, sir.
Here x tends to 0 plus means x is a positive number. So a positive number divided by the same number, it is always 1. Now if I consider the left hand limit, x tends to 0 minus. Okay. So now you might know, if x is negative, mod x is minus x. Do you know? Because if I choose a negative number, maybe minus 5, the answer is positive, isn't it? Positive means actually it is negative of the original number. It is negative of the original number is minus 5. It is negative of the original number, isn't it? So if x is negative, in this case x is negative, it means mod x is, yes, it is minus x.
Yes, sir.
Now again x is here not 0, x is a negative number. So a negative number by another negative number, we can have some number. So it is a negative number by same negative number, it is 1, but I have minus sign here. So here the value is minus 1 because I have minus sign here. So you see, both limit exists, left hand limit, right hand limit, both limit exist, but here the values are different. One is plus 1, one is minus 1. So we say that limit does not exist. Okay, if you want to try yourself, what you can do? Because x tends to 0 means, what does it mean? X is very close to 0, but x is not equal to 0. Yes, try one number which is very close to 0 from the right hand side. That is, try one positive number and one negative number. Maybe positive number you choose 0.01. It is close to 0, and one negative number maybe 0.01 but negative. So if you choose this one, what do you get here? Mod x by x, it is 0.01 mod by 0.01. What do you get? You get 0.01 by 0.01. You get 1, isn't it? But again, if you choose a number very close to 0, like 0.01 but negative of that, so what do you get? Mod of minus 0.01 by minus 0.01. What do you get here? Here you get, yes, 0.01 in the numerator, and denominator I have minus of 0.01. What do you get? You get minus 1. Let me discuss something more. Okay, suppose x plus 5. Okay, whenever there is no confusion, okay, we need not write left hand or right hand limit. So let me write here the answer directly. Limit of this function x plus 5 when x tends to 2 is 7. Why? You may think that we can put x equal to 2. No, actually the meaning doesn't say that when x is equal to 2, 2 plus 5 is 7. It is not so. What does it say? Whenever x is very close to 2. Here I haven't used left hand and right hand separately, but if you want, you can write 2 plus and 2 minus separately. Suppose we consider separately, whenever x is very close to 2 but greater than 2, what do I get? X plus 5 will be very close to 7, isn't it? it is slightly greater than 7, but it will tend to 7 plus, isn't it? If
Yes,
x
sir.
is
Yes, sir.
very close to 2, that is, if x is close to 2 plus, I will get 7 plus, means very close to 7. Similarly, if I get x tends to 2 minus, that is, x is very close to 2, but slightly less than 2, this will give x plus 5, again 7 minus. That is almost approaching the same number, isn't it?
Yes, sir.
Whether
Yes,
you
sir.
consider right hand limit or left hand limit, in short, the meaning, as I said, the meaning does not mean that 2 plus 5 is 7. The meaning says whenever x is very close to 2, x plus 5 is very close to 7. That is the meaning. Let us consider again 2. Suppose here x minus 2 and x square minus 4. Now again you can see, of course here we cannot put x equal to 2. Earlier we could, but the meaning of the limit is not that we are going to put x equal to 2. We will put something closer to 2. Now if you want, you can try some number, maybe x equal to 2.001, but we will try to find it formally, okay, or mathematically. So although we don't know to which number this particular function is close, but we know we can write this function in simplified form like this. Yes, all of you know.
Yes, yes, sir.
Yes, sir.
Now, as I said, x tends to 2 means x minus 2 is very small, but it is not equal to 0, because x not equal to 2. We are going to put something closer to 2, but not 2. So x minus 2 is not 0. It may be positive, may be negative, but it is not equal to 0. So x minus 2 is a number, but it is not 0. Means these two are the same number. What I can say? I can say they will cancel out and I get x plus 2, because x minus 2 is not equal to 0. It is something very close to 0, but not 0. So I can cancel them out. Yes or no?
Yes, sir. Yes, sir.
Now I have a situation like as before, x plus 5, 7. So now if I choose a number very close to 2, what do I get? X plus 2 will be very close to 4, isn't it?
Yes,
Any
sir.
doubt? Any of you? I think you should not have any doubt. If x is very close to 2, maybe slightly greater than 2, or maybe slightly less than 2. If you want, you can compute left hand limit and right hand limit separately. But here it is obvious whether it is very close to 2 from the right or from the left. But x plus 2 will be very close to 4. Yes?
Yes,
Yes,
sir.
sir.
Yes, sir.
Similarly, you can consider some other function. Okay, let us try to consider. Okay, something like this, x minus 2. Suppose x cube. Now consider x cube minus 2 cube is 8. Okay, let me write here. So similarly, I can proceed. Okay, what I can write? You know, I can write here x minus 2. If I expand it, x minus 2, here I have x square plus, it is twice a, is it? Twice a plus 4. Is it? If I expand a cube minus b cube, I can write this way? Yes or no?
Yes, sir.
Yes, sir.
Similarly here, because x minus 2 is not equal to 0, they will cancel out. I can write this way. Now similarly, you can verify easily. If you choose a number very close to 2, this one will be simply, if you put the value x equal to whatever you get, that will be the answer. You can try twice x, isn't it? Okay, twice x. So you get something like this, 2 into a plus 4. You will get the same number, whatever you get after calculating. Okay, so it is 4, 4, 4. It is, yes, 8, 12.
16.
Is it?
12.
It is 12. Okay, so you can say, although I have directly put here x equal to 2 in place of, okay, the function, but this one is not so. Actually, you should write the expression equal to 12, because you are not going to put x equal to 2 here. You are going to, you understand it? You cannot write actually this way. This one is wrong, because you are not going to put x equal to 2. You are going to put x is something very close to 2, and you see that the expression will be very close to 12. So this part is actually incorrect. You should write this part equal to 12. But you can see by putting x is x very equal to 2, you will get the expression very close to 12. Okay, let me give a few results, then we will try some problems in the next class. So here I considered x square minus 4, or x square minus a square, and x cube minus a cube. So let us give you as a real expression. Now one, suppose x tends to Okay, consider suppose a, sum a, maybe c you can write. Suppose x to the power, I consider a equal to 2, but here I write the general expression and x to the power n minus e to the power n. So here x minus a, I consider x square minus a square, x cube minus a cube. So if I write this way, general form, the value will be a to the power here n minus 1. So this is the general expression. Definitely a should be positive. Okay, here also you can write what is n. N is integer, or you can choose any rational number too. It is one result. Do you get it? This one is a general form of what we computed. Okay, the other you can right. Suppose x tends to 0. Okay, suppose sin x by x. Okay, sin x by x, if you find the limit will be equal to 1. What does it mean? If you choose a number very close to 0, you try it, sin of maybe 0.00001, whatever you get, divide that by the same number 0.0001, you will get something very close to 1. That is the meaning. X tends to 0. If I consider this one x to the power x, it is 1. Yes, if you choose a number very close to 0, okay, x to the power x will be equal to 1. Preferably here you can say x, 0 plus actually. Okay, let us write x tends to 0. Okay, 0 plus or 0. 1 plus x to the power 1 by x. So this particular function, if I take x tends to 0, is a number closer to 0, and take this particular function, it is a special number. Okay, you have to memorize this symbol. It is e. E, it is approximately equal to 2.71. In other words, you can write, suppose limit, maybe you can write n, okay, 10 to infinity. Some of you have used this particular symbol, but you don't know what is e, isn't it? E is something, this particular limit. If we consider 1 plus x whole to the power 1 by x, x tends to 0. When x is very close to 0, you will get a number. That number is known as e. That is e. The meaning of e is this one. Or you can write in this way. It is if n is something very big, n tends to infinity means if n is something very big, then you consider 1 plus 1 by n whole to the power that big number, very big number. So you can try n equal 1 crore, then 100 crore, maybe you can then check, it will be something very close to a number that is known as e. Now using e, we can consider another function, that is e to the power x minus 1 by x. If you consider this one, if you put the value of e, then if you take x tends to 0, that value is 1. This one is important.